Here are the answers to Unit 2 for response question number 2. As usual, do these two things. All right, first one gives you a scatter plot predicting height from someone's foot length and gives you regression output. You need to learn how to interpret the values on this table, and says calculate and interpret the residual for a high school senior with a foot length of 20 centimeters and a height of 160 centimeters. So first step in the answer is knowing what a residual is. Residual is the actual minus the predicted. So if I take 20 centimeters as an input, I need to get the predicted value by plugging 20 into the equation of the line. Using the output, if y is the height and x is the foot length, this row here, foot length, is the x, and the slope goes next to the x term. And then the top line, constant, is the y-intercept. So the regression equation is y-intercept plus 2.599, which is the slope times the length. If you plug 20 into that regression equation, you wind up with 157.06. That's the predicted value, so the residual is 160, or the actual value, minus 157, which is the predicted value for a residual of 2.94 centimeters. Essentially, correct criteria is down here. You need to have three components. The formula for the residual, actual minus predicted. The interpretation, actual height compared to the predicted height, and then context, which is it taller or smaller? Since the residual value is positive, that means the actual number is greater than the predicted number, or the line is below the actual value. Part B is interpreting a single number from the regression output. The standard deviation of the residuals is s equals 5.9. Interpret it. Again, knowing what a residual is will help answer this question. Residual is the difference between the actual y value and the predicted y value, and you go in a straight vertical line. So for each input, a data value has a residual value. S, or the standard deviation of the residuals, is the variability of these vertical lines. So actual heights for the high school seniors typically vary by about 5.9 centimeters from the heights predicted by the least squares regression equation using x equals foot length. So for each x, the typical deviation, or the typical residual, is 5.9 centimeters. Essentially correct if you have comparing actual to the predicted, or points in a scatter plot with the least squares regression line. A picture would help satisfy that. Interpretation includes the idea that standard deviation measures typical or average distance, and interpretation uses the variable name height. Part C, here's a histogram of all 65 residuals. Assume the distribution is approximately normal with a mean zero and a standard deviation of 5.9. What percent of the residuals are greater than 8 centimeters? So assuming this kind of a distribution, what are the chances that I get 8 or greater? So this is another bell curve calculation. If something is normal with a mean and a standard deviation, you can draw your diagram, calculate your z-score, and then calculate your percentage. The percent of residuals greater than 8 centimeters winds up being 0.0869, or roughly 9% of the residuals are greater than 8 centimeters. To get essentially correct for this question, make sure that you summarize the information given. A diagram is a great way of doing that. Response indicates the values of interest are greater than 8. Find 8 on your diagram, and answer consistent with the components 1 and 2. Calculation at the end of about 9%. And then finally, using your answer to Part C, and this is important, would it be surprising to randomly select a high school senior from the high school with a foot length of 20 centimeters and a height greater than 165 centimeters? Justify your answer. So this question is actually based on both parts A and C. If the height is greater than 165 centimeters, and if you're going to have a length of 20 centimeters, in Part A, we took 20 centimeters, plugged in the regression equation, and got a predicted value of 157.06. If you compare the predicted to the actual, that difference is 8 centimeters. So a residual of 8 centimeters is, as we found in the previous question, going to occur about 9% of the time. Something that occurs 9% of the time is not rare. A lot of people had 9% as a correct number and then said, yes, that's rare. Generally, anything below 5% or 1% is considered rare. So the correct answer here would be no, it's not rare or unexpected. Essentially correct, again, has three components. Height of 165 centimeters is about 8 centimeters greater than the predicted, or a residual of 8 centimeters. Use the value of part C. So the previous question, getting about residual of 8 centimeters, occurs about 9% of the time. And then answering the question, state that selecting such a high school senior at random would not be surprising. And this is the part that a lot of people did not do correctly. 9% is not considered rare. And here's the grading. This was graded out of 4 points. Since there were 4 parts, each part was 1 point for being essentially correct, half a point being partially correct, and then summed. And if there was a sum of a half point, it was rounded up or truncated down depending on how much work you showed or how holistic grading pointed you in up or down.